So today we're just going to go over quickly how to graph simple exponential functions. We'll get into more complicated ones a little bit later in the unit. So we are looking at graphing 2 to the x power. And remember that x is your domain, and we are trying to figure out what values of x can you plug in into the exponential function to the x power. So sometimes when I'm looking and trying to figure out the domain, I just ask myself, is there any reason why you couldn't put some negative numbers up in the exponent? And I go, no, because I could just write that as 1 over 2/4, right? Using my rules of exponents, which would be 1 over 16. Can I put a 0 up in the exponent? Sure, that's just 1. Can I put positive numbers up in the exponent? Sure. So my domain is all real numbers. So I can plug in negative numbers, I can plug in 0, I can plug in positive numbers. So I'm allowed to plug in any numbers I want for x because it's not going to be a problem. Therefore, if the domain is all real numbers, it's always a good idea to plug in some negative numbers, 0 obviously, and some positive numbers. And then we're just going to plug in chug. We're going to plug -2 in where the x is and evaluate. So what do you get when you have 2 to the -2nd power? Isn't that 1/4? And if you're like, oh, where's that coming from? Well, didn't we learn in the last unit that we could write that as 1 over 2 squared? And then isn't 1 over 2 squared 1/4, right? And then we're going to do 2 to the -3. So now we're going to plug in, we're going to plug in -1 in for the x. And so what do you get when you plug in 2 to the -1? Isn't that 1/2? And then what do you get when you plug in 2 to the 0? That is 1. And then 2 to the 1st power is just 2. And then 2 squared is 4. So now we're just going to graph that t-table. So -2 to the 1/4 is about right there-ish. -1 to the 1/2, we can find that one. That's right in the middle. 0, 1, 1, 2, 2, 4. And if we wanted to, we can add as many as we want. Don't have to. We can already see what the pattern's going to be. If I want to do 3, 8, and then we can see it goes something like this. It should have arrows on both ends. And this is an asymptote. This is called a horizontal asymptote. What that means is the graph is going to get closer and closer and closer to the x-axis, but it's actually never going to actually touch it or cross it. It looks like it touches it now because, right, we can't see, but it technically doesn't cross it or touch it. And that's what we call a horizontal asymptote. So this one will have a horizontal asymptote. And a lot of times we don't like to spell out the words, so we might use HA for horizontal asymptote. And the equation of that line is y equals 0. That is the equation of that horizontal asymptote, and we like to do asymptotes in dotted lines. So your graph should have the horizontal asymptote in it at all times. So let's try another one. Now, shouldn't you have noticed that because the base was 2, you should have already known that this was going to be an exponential growth, right? Because the pattern is times 2, times 2, times 2. And the numbers are just going to get bigger. So it's going to be growing and not decaying. And we should know the general shape of an exponential growth is going to be something like this. So we should have been able to look at it and know what the general shape of it's going to be. So let's look at another one. So this time the base is 1/2. And we should know if the pattern is that we're multiplying by 1/2, multiplying by 1/2, then we know the numbers are going to get smaller. And so we should know that this is an exponential decay. And we should know the general shape of an exponential decay looks something like that. So since the domain is all real numbers, so the domain is all real numbers, that means we can plug in negative numbers are going to be fine. So we should always plug in a few negative numbers, and some positive numbers and zeros are always good to plug in. So what is 1/2 to the -2nd power? Didn't we learn in the last chapter that we can get rid of the negative exponent by reciprocating the base, and that will make that 2 squared, which then makes that 4. And then what is 1/2 to the -1st power? We learned that you can reciprocate the base, and that will make that exponent positive 1. So that's just 2. And obviously, anything to the 0 power is just 1. And then 1/2 to the first power is just 1. And then what about 1/2 squared? That always throws people off. What is 1/2 to the second power? Well, remember what exponents mean. What does 1/2 squared mean? Doesn't that mean 1/2 times another 1/2? So isn't that 1/4? So we can go ahead and graph those. So -2, 4. We could have done -3, 8 if we wanted to. We got -1, 2, 0, 1. 1, 1 is not right. When you plug in 1, you get 1/2. I think I said 1/2, but I didn't write it. So 1/2 to the first power is just 1/2. So 1 to the 1/2 is right in the middle. And then 2 to the 1/4 is right about there. And remember, it starts coming up high and then it starts to drop. So we have less and less people infected. Our money, we're losing money. So we started off good money. Maybe the stock market started to decline or decrease exponentially. And we also have a horizontal asymptote where it's approaching that horizontal asymptote. So that's the HA. And the equation of the HA is y equals 0. So this is your horizontal asymptote, which is y equals 0. And the range, I think my husband's home, is y is greater than 0. And that's just a simple example of how to graph exponential growth and exponential decays. Ciao, ciao.